So we come to the last presentation of the conference, and it's my pleasure to introduce Nikolai Meyer from Skansen Akvarit, who's going to talk about the evolution of this 30-year-old reef tank. Nikolai?
Thank you. Hello everybody, my name is Nikolai Meyer and I work as the aquarium curator at the Skansen Aquarium in Stockholm. During a renovation of our zoo in 1999, a large reef tank was built and it opened in 2000. I'm going to talk about some small details, construction-wise, that made life a bit harder for keepers than what was necessary. And I'm going to talk about some of the challenges that have occurred during the last 13 years. The volume of the reef tank is approximately 11,000 liters. It has a curved acrylic panel, which is 6 meters long and 1.4 meters high. The tank is built in polyester with a steel frame, which is coated with an epoxy sealant. Aquascaping was made from natural dry live rock put together with PVC rods, cemented together with Portland concrete mixed with a silica polymer, so no unwanted stuff was released into the water. And then later we added 100 kilos of matured live rock. Filtration for this exhibit was kept to a minimum, as space for filtering equipment was limited to an 11 square meter basement room, as you can see in the picture. And that room was shared with 3 other reef systems, so there was really no room to put anything. So it was decided that the Berlin method was the way to go for filtering the water. The water flows from the display tank through an overflow chamber with 2 100 micron filter sucks down to the filtration room, into the filtering tank, which is located in the basement. The filtration tank is a double-chambered fiberglass construction with a volume of approximately 1,500 liters, and that is about half filled with live rock. Then the water goes to a DIY protein skimmer with double venturis, and it's made of fusion-welded PVC. The contact chamber is about 80 centimeters in diameter and 2.5 meters tall, and is supplied by an EUAC MX400 pump, which pumps approximately 280 liters a minute. That pump also supplies 4 55-watt UV sterilizers and a 200-liter calcium reactor. Lighting for the display is provided by 8 400-watt metal halide lamps and 1 100 LED light, which are placed between 30 and 60 meters above the surface. Recently, we have added 3 60-watt T5 moonlights to smooth the transition between day and night for the animals, since we can't dim the headlights. Maintenance consists mostly of window cleaning, algae picking, chemical additions, and vacuuming the bottom every 2 weeks. Window cleaning is being done both from the inside and the outside due to tank design, where there are a lot of unreachable spots due to the reef structure. At some places there's between 20 and 30 meters from the rock, 20 to 30 centimeters between the rock and the window, which doesn't give you much space either for cleaning it from the outside or diving. Water movement originally consisted of 1 280 liters a minute return pump plus 1 280 liter a minute circulation pump, and that worked fine in the beginning, but then corals started to grow and they disrupted the established water flow, so we had to put in additional pumps, and that proved challenging due to the design. There was nowhere to easily hide either submersible pumps, water outlets, even less pipes, since all of the reef structure was cemented together. But we managed through the years to hide 2 submersible pumps and 2 water outlets for an extra circulation pump. The display has been dosed with 20 grams of calcium hydroxide daily since startup, but in recent years and since coal started to grow, that doesn't really cover the demand for the tank. So we added a 200-liter calcium reactor, which worked only temporarily since stuff kept growing. So now we add calcium chloride daytime and calcium hydroxide at night. Magnesium is added daily, strontium chloride and potassium iodide is added irregularly based on test results. Sodium carbonate, bicarbonate, we add only if we see any fluctuations in the pH. Now to the interesting part, the problems. Originally, the tank had a sand bottom with a 5 to 8 centimeter sand bed, but without a plenum, so it was placed directly on the bottom. And the water movement was designed so that all the suspended solids in the water would settle on the bottom. And that soon turned out that detritus and cyanobacteria were flourishing on the sand, requiring daily vacuuming. So after doing that, a couple of months, it was decided that the sand should go. So we took all the sand out, which made life a lot easier. Aptausia, most of you probably had that problem, covered up almost every available spot in the exhibit at one point, and one idea was to fight it with hydrogen peroxide injections. That was thought to be a good idea, but that was a battle that could not be won. It would take like weekly dives of an hour to kill maybe 20 Aptausia. So then we bought a Shalmandostratus, and after 4 weeks in there, he cleaned the whole tank, leaving only the ones at the surface, and that it didn't cause any problems for our corals. Temperature control is another big issue, because when constructing the filter room, as you saw, it was 11 square meters. There wasn't room for any chilling devices, so we contracted a cooling company to come up with a solution, and they put in air coolers in the ceiling, which cooled the air instead of the water. A bit weird, but it worked during most part of the year, except for summer, where the temperature increased to 28 to 29 degrees. So we installed a large fan that blew cold air across the surface of the display, and that helped the air coolers doing their job. But then again, another problem. After a couple of years, the air coolers started to corrode. Even though the aluminum that was inside was epoxy coated, just the humid and salty environment that they were working in caused them to pulverize. So that forced us to replace the air coolers every 2 to 3 years, and they're pretty expensive. So last year, we put on a bypass on the skimmer pump, and we connected a titanium plate heat exchanger. So now we can keep the temperature stable at 26 degrees all year round, which is very convenient. Myriniuma. Since start of the display, the only thing that we quarantined were fish that the boss thought that what could you probably introduce into a tank that was sitting on a rock. So that caused the usual problems like Aptausia outbreaks, mantis shrimp introduction, and whatnot. But then one day this little critter appeared, this little brown hydroid, and it wasn't considered to cause any problems. And it was actually quite attractive at the beginning, but it soon spread and started to sting nearby corals, causing some casualties. Since then, we have tried manual removal, most biological treatments that we could find, like different fish species, urchins, sea hares, starfish, but we haven't found anything yet that would ease the problem. So if any of you have any special secret treatments, please contact me afterwards. Power failure. on average, we have at least one power failure a year during the last couple of years, lasting everything between 10 to 15 minutes to hours. But it's always due to reasons out of our reach, mostly caused by digging machines cutting cables at construction sites nearby. Then, due to the placement of the overflow from the tank, the top 30 centimeters of display empties downstairs into the filter tank, causing it to overflow, which then empties into the drain, which then causes the return pipe up to the tank to backflow from the return pump, emptying the display even more. So then, when the power comes back, there's not enough water in the filter tank, causing the pump to run dry and breaking down. Very expensive pumps. So now we have installed the backflow valve, preventing this from happening, if it doesn't get clogged. Happened once. Lighting. Well, during the construction of the tank, someone decided that the decor on the outside of the tank would be built over part of the surface of the water of the tank, making visitors get the impression or a sense that they're walking on the water. What wasn't considered then was that it would limit the options of hanging lighting fixtures, and thereby creating an uneven light distribution, creating shaded spots. And actually, we haven't found any good solution for this yet, but we're working on it. It's too expensive to remove the wall and make like a straight wall over the tank. Magnesium. Magnesium levels were tested in the first few years of the tank, and they proved stable at around 1200 to 1300 ppm. And at that time, that resulted in the belief that with regular water change, this would stay so. So probably during 8 years, we didn't do anything. But then, by chance, we tested the magnesium, and after years of coral and calcareous algae growth, magnesium was depleted to around 700 ppm. But the corals didn't seem too affected, though they weren't growing very fast. So now we have to add magnesium at a regular basis. Nitrate has become another problem. So during the recent years, nitrate has become a problem and could not be controlled with the water change. Well, in the beginning it was controlled with the water change, and there we could keep the concentration between 10 to 20 milligrams a liter. But in the last few years, the density of fish has increased, causing the nitrate to rise to about 20 to 40 milligrams per liter. And changing the water is very expensive and really not an option for us, so we had to seek other solutions. And since we already had an ethanol-fed DNF filter on our touch pool, we had a fair amount of 99% alcohol. So we decided to experiment it with the in-tank carbon dosing, despite warnings of old tank syndrome and such. But there wasn't really any time or money to build a new DNF filter. So we diluted the ethanol to about 20% instead of the usual 40% that most hobbyists use, just to start things slow. The ethanol was added at a dosage of 0.1 milliliters 3 times a day, and after 6 weeks we didn't see any effects, nor could we see a reduction in nitrate. So we increased the concentration to 40% alcohol during a 3-week period. And after 4 weeks, we saw a slow decrease in nitrate, but then the display water turned cloudy. So, and we experienced an explosive increase in tiny copepods gathering on the window, probably caused by the excessive bacteria bloom. Since then, we have diluted the alcohol back to 20% again to get rid of the cloudiness, and with a slight increase in nitrate to around 20. But in a couple of months, we'll probably give it another try and raise the ethanol concentration, hoping for less bacterial bloom. But you can see on these pictures that the water gets pretty cloudy. So, conclusion. Overall, the exhibit has been a success. Coral, fish growth and coloration is acceptable. Water chemistry values fall within acceptable ranges. But when designing new displays, keepers should be involved in the process to avoid some basic mistakes that we can all live without. But then again, on the other hand, a reef tank's environment is always changing. So one comes to the conclusion that what worked in the past will probably not work in the future. This paper would not have been possible without the valuable contribution of my predecessor, John Hontalas, which most of you probably know. And thank you for listening.
Okay, thank you, Nikolai. Now here, I expect there must be questions. Yes, Max. Moment. Excuse me.
You were mentioning you were adding magnesium after a while. At what level is it now?
It's around 1100.
Okay, because we had also a lot of Myrionema problems with the hydroids, very aggressive, and when we added a lot of water movement and a lot of magnesium, going up to 1250, we saw it depleting. There was less Myrionema, so maybe it was because of magnesium increase, while then you get more calcareous algae growth and more competition on the surface. So that's why we thought that the Myrionema left us, but of course we are not sure, but it's maybe something to consider to increase it even further.
I think our target number is 1300.
Yeah.
Okay, any other questions? Pete.
You said that you were adding potassium iodide after you measure it. How did you measure it?
We measured it with a hobbyist test kit from Salifert.
Okay, thanks.
Very inaccurate, but very cheap.
Yes, that's true.
I will shout, no problem. What happened to the phosphate concentration after addition of the ethanol? Did you measure?
Yes, we measured that. Phosphate is also starting to become a problem, but we were hoping that it would also ease the phosphate problem, but it stayed stable at 0.1. Didn't decrease, didn't rise. But hopefully, in the next few months, when we'll increase the concentration, that some bacteria will take care of that as well. So we get like a slight decrease. That's my hope.
Okay. I have a question myself then. Your German Rostratus, was the animal trained before it went in? Was it trained to eat, or just went and did its thing? And...
No.
Wow. Thank you.
He's still with us today.
Great. Thank you, Nikolai.
We love him.